Okay, with 7.5, we're going to have exponential and logarithmic equations that we're going to solve. Okay, so we're going to start with exponential first. If I have 4 to the 2x plus 2 power, and that is equal to 64 to the x minus 2 power. Now that y'all have done 7.3, you should be able to look at that, and you don't need any knowledge of 7.5 to be able to solve that. Okay, if I have a 4 and a 64, what could I do? I'm going to change the larger number down to the smaller base, just like we did in 7.3. Okay, so 64 can now have a base of 4, and that is 4 cubed. So I've got on the right side 4 cubed raised to the x minus 2 power, and that 4 to the 2x plus 2 power on the left stays. So if I have two sides of my equation, both raised to an exponent, and I can get like bases, then that's what I'm going to do. That's the easier way. Okay, so then this is 4 to the 2x plus 2 power equals 4 to the what power? What am I going to do if I have 3 raised to the x minus 2? I'm going to multiply, and that becomes 3x minus 6. Now I have my one-to-one property set up. I can set 2x plus 2 equal to 3x minus 6. And I just solve for x. Okay, you could subtract your 2x and add your 6, or you can subtract your 3x to get a negative x, subtract your 2 to get a negative 8, divide by negative 1, x equals 8. Okay, now with 7.5, you get to use the inspire. You can check every single one of these problems because you're getting x equals as your answer. Okay, so for you to check in the inspire, you're going to type your number and then control var will get you that store arrow, and then you type your x. Okay, so I'm going to show you this one, but I'm not going to check every single problem because of time. So I'm going to type my number 8, and then control var is at the top, control var, and then that x, and then I can type 4 raised to the 2x plus 2 power, gives me that long number, and then I type my right, 64 raised to the x minus 2 power. It should give me the same exact value if it's true. Okay, so you can check every single one of those in 7.5. Okay, so my next example, I have 4 to the 2x minus 1 equals 8 to the x plus 2 power. Now that 8, I cannot manipulate to become a 4. Even though 4 times 2 is 8, 4 squared is not 8. So what am I going to have to do with 4 and 8? I can make them both a base of 2. So 4 is the same as 2 squared, and that will be raised to the 2x minus 1 power. And then 8 is the same as 2 cubed, and that is raised to the x plus 2 power. And then we would simplify our exponents. So the left side would be 2 raised to what power? 4x minus 2 equals 2 to the 3x plus 6 power. Okay, and then I'm at the point where I can set 4x minus 2 equal to 3x plus 6. Okay, I would subtract my 3x, add your 2, x equals 8. If you're doing it on your own, I would check it. For time's sake, we're not going to. Okay, but I would check every single one of your problems, especially on the quiz and the test. Okay, so my next problem I have, I'm not going to do it, but I'm going to write it in case you want to work it on your own and check the copy of the notes. The 6 raised to the x power equals 42. This is a very simple one. I'm just going to do the one where you have to isolate it. Okay, so if I have 7 raised to the 5x minus 1 power plus 2 equals negative 5. Notice that with both of these examples, I can't do the same thing that I did with the first two because the first two had exponents on both sides, left and right. Here, I only have one term with an exponent, so I'm not going to treat that the same, okay? What I'm going to do is always try to isolate the base raised to the exponent because these are exponential. If you don't have the word log, then that means it's exponential, not logarithmic, okay? So if it's exponential, I want to isolate the base raised to the exponent. So the example that I skipped is already isolated for me. That's why I'm not messing with that one. If you can do this, then you should be able to do that. Okay, so if I'm isolating 7 raised to the 5x minus 1, I'm going to subtract my 2, and that leaves me with 7 raised to the 5x minus 1 equals negative 7. Once you isolate your base, okay, I've said it's exponential. What's the inverse of exponential? Logarithmic. So for me doing the inverse, it's not a matter of me adding and subtracting. It is me rewriting it. So you will rewrite it in logarithmic form. Okay, so remember your logs, you have log base solution equals your exponent. Okay, so you are going from exponential and writing it as a log. Okay, so if you need to see that 7 is your base, that 5x minus 1 is your exponent, that negative 7 is your solution. Okay, so when I rewrite that as a log, I have log base 7 of my solution, negative 7, and that is equal to the 5x minus 1. So it's kind of like you're going in a counterclockwise direction. Okay, now at this point, I should be able to type in log base 7 of negative 7 and just get a value. And then I can start solving for x. When I do that, in my Inspire, if you look at the buttons to the left of 1, that is your natural log and log button. Okay, so I'm going to do control log. And I've got log base 7 of negative 7. It should give you an error message on your calculator. What rule am I breaking with log base 7 of negative 7? I introduced it to you last class, and this is a negative. You cannot take the log of a negative number. Because I cannot take the log of a negative number, I have no solution for this problem. Now I'm hoping after me emphasizing that for this problem, the moment you take the log of negative or log of 0, you automatically know it's no solution. But you have to prove it by rewriting it. Okay, I saw yesterday some people were jumping straight from this to no solution, and you cannot do that. Okay, you have to rewrite it as your log. So if I look at the next one, I have 2/3 e to the 2x power minus 6 equals negative 3. Okay, if I have that, I'm still an exponential. I want that e to the 2x by itself. So I'm going to add my 6. So 2/3 e to the 2x equals 3. And then I want to get rid of that fraction. If it's 2/3, I'm going to multiply by the reciprocal, and I have 3/2. That will cancel the fraction, leaving me with e to the 2x power equals 3 times 3/2 will be 9/2. Okay. And then I've got my base isolated. I need to rewrite it. Log base solution equals exponent. Now my base is an e, so am I going to do a normal log? I do what? Natural log. So 2x is my exponent, 9/2 is my solution. You do not have to label those. I'm just going to do that for the first few. Okay? So when I rewrite it, I have the natural log of 9/2 equal to 2x. I'm not writing the base of e because it's already understood to be e when you write a natural log. If you write the e, that is totally fine if you need to. I'm not going to count off for that. All right, so if I have natural log of 9/2 equals 2x, I'm going to type the natural log of 9/2 in my calculator and get a decimal. Okay, so you'll do your control and then natural log. To get a fraction, control divide gets you that template. You can type your 9/2. Okay, so that tells me that the natural log of 9/2 is equal to this decimal. I'm going to round it to 4 decimal places. So I have 1.5041, and that is equal to 2x. And then to solve for x, what do I need to do? Divide by 2. Now, if you just type divide by 2 and you use the previous answer, that's going to give you a very long, the actual accurate decimal divided by 2. That's fine if you do that, but your answer might be a little off of mine. Okay, so you can either use the same thing in your calculator or you can retype 1.5041 divided by 2. It is just a little bit off. Okay, so this x is equal to 0.7521. If you use the rounded answer within your problem and you store that for x, then when you type your original, that 2/3 e to the 2x minus 6, it will not give you the full -3 as a whole. That's okay, because what did you do? You rounded it within your problem. So you're basically double rounding. It's going to be a smidge off, but that's fine. As long as it's super close, you can see that that's pretty much a -3. Okay, if you use the full answer, not rounded, and store that for x, that will give you the -3 that you need. I'm okay with either one. Just make sure on your paper it's still rounded to 4 places. Okay? Just letting you know so when you check it. All right? Okay, the last one we're going to skip. I'm going to write it, but we're going to skip it. That is 4e to the -0.3x minus 7 equals 13. If you want to work it out on your own and check it with a copy of the notes, you can. But if you can do the fraction, you can do that. Okay? Now we're going to look at 8 raised to the 2x minus 5 power equals 5 raised to the x plus 1 power. Okay? Now, when you look at this, this is similar to the first two that we did in the fact that you had two terms, both of them had an exponent. On the first two, we were able to do the one-to-one property. If I'm looking at these numbers, I cannot change 5 or 8 to any other base to be a one-to-one property. So if this is the case, then what you're going to have to do is take the common log of both sides. Because this is exponential, the inverse is log. So you're going to take the common log of 8 raised to the 2x minus 5 power and the common log of 5 raised to the x plus 1 power. So you take the log of both sides. Okay? Now when I do that, I still have my x that I'm solving for in the exponent position, which I do not want. So what property can I use to take that x from exponent and put it down to a normal position? We did that in 7.4. We took our exponent and we made it a coefficient. So even though you have variables, you can still do that with your exponent. Okay, so that just means in parentheses, I have 2x minus 5 times my log of 8. And that is equal to that x plus 1 in parentheses times your log of 5. So all I did was take those exponents, move them to the front. Okay. Now I've got my x's in a normal spot, but they're in parentheses being multiplied by a log with a constant added or subtracted. So the only way you can break that apart is if you distribute that log of 8 to both of those terms and that log of 5 to both of those terms. Okay, so that means it's going to be 2x log of 8 minus 5 log of 8 equals x log of 5 plus just log of 5 because that's being multiplied by 1. Okay, so I distributed the logs to each term. Now I have an x on the left and an x on the right. If I want an x, what am I going to do? If I know my final answer is x equals a number, I need to get those x's on the same side. So that means that negative 5 log of 8 needs to be switched also. Okay, so I'm going to have that 2x log of 8. How am I going to move that x log of 5 to the left? I'm going to subtract the minus x log of 5. That is going to equal the log of 5 on your right, then plus the 5 log of 8. Okay. Now I've got my x's on the left. Can I make that a 1x? Notice these are not the same logs. If this were 2x log of 8 minus x log of 8, then yes, that could become x log of 8. But because they are different logs, those are not like terms. I cannot make that a 1x. So the only way you can go from 2x's to 1 in this situation is if you factor out that x as a GCF. So if I take that x out as a GCF, what am I left with? The 2 log of 8 minus the log of 5. And that is equal to the right side, log of 5 plus 5 log of 8. Okay. Now I need x by itself. X is being multiplied by this entire thing. So the opposite of multiplication is division. I'm going to divide the entire thing by this. Okay, so x is equal to the right side, log of 5 plus 5 log of 8, divided by 2 log of 8 minus log of 5. Now, since this is a common log, you can either type this in your scientific or your Inspire. Okay, you'll have both in this portion of the test, so it doesn't matter which one, whatever you're more comfortable with. If you want to do it in the Inspire, control divide, get your fraction. When you do the log, you just have to know your common log has a base of 10. So you have log base 10 of 5 plus 5 log base 10 of 8 divided by 2 log base 10 of 8 minus my log base 10 of 5. You just have to be very careful when you type 10. Okay? That's going to give me that rounded decimal. Okay, so that is 4.7095. Again, it's rounded, so if I store this for x and I type my original two sides, they might not be exactly the same, but they should be very, very, very close. Okay? Y'all understand what I mean by that, right? With it being rounded? Okay. All right, the next example, I don't have all the time to do, so I'm going to write it. Again, if you want to practice it, you can. But I will say I omitted the problem like this on your worksheet when we get to that, so you don't have to practice this one. It's just extra, but I did take it off. Okay, so this is the fourth root of 3 to the 4x plus 5 power underneath the radical, and that is equal to 7 to the x power. That one, you would just rewrite the radical in rational exponent form, clean it up, and then treat it the same way as this, okay? But again, I'm going to end up omitting that on the worksheet, so if you don't want to look at it, you don't have to, okay? Are we good with exponential? So when we do logarithmic equations, now in these notes, I'm separating exponential from logarithmic. In the worksheet, it's all mixed together, and I just find it log. Okay, so if it has the word log, then you know you're dealing with a logarithmic equation. Okay, so remember that you cannot take the log of 0 or a negative. So don't forget that when you're working on these. Okay, so if I have 2 log base 6 of 2x minus 5, and that is equal to 4. Okay. Our 7.4 properties told us that if we had a coefficient, that really meant that it was an exponent. We do not use that property unless you are condensing. Okay? Here, I'm not condensing. I already have one log. There's going to be problems where you have multiple logs. If you're condensing, you use that property. Here, I'm not going to. I want this log base 6 of 2x minus 5 by itself. So I'm going to divide everything by 2. When I say I divide everything, that just means the left side and the right side. What is inside parentheses will never change. So you dividing by 2 just cancels out that coefficient. And that leaves me with log base 6 of 2x minus 5 equals 4 divided by 2 is 2. Once you get your log by itself and isolated, what is the inverse of log? Exponential. So you are going from your logarithmic and you're going to rewrite it to exponential, which is your base raised to the exponent equal your solution. Right? And right now we have log base solution equals exponent. So we're going to rewrite it. If you need to label it, this is your base, this is your solution, this is your exponent. Okay? So when I rewrite it, I have 6 squared equals 2x minus 5. 6 squared is 36, equal to 2x minus 5. I want to add my 5, so 2x equals 41. Divided by 2, bless you, x equals 41 halves. Or if you tell me 20.5, I'm okay with that too, because we can round our decimal answers. So it doesn't matter which one. Now, when you have log equations, these are the ones, if you don't check your exponential, you have to check your logs, because you have to see, are you going to end up taking the log of negative or log of 0? Okay, so here, if you had your 41 halves in your calculator, you'll take that, store it for x, and then type your 2 log base 6 of 2x minus 5. It gives me 4, so I know I'm okay. All right, so you have to check for extraneous solutions. Okay. Now this next one, I have the natural log of 7x minus 4 in parentheses equals the natural log of 2x plus 11 in parentheses. Okay. Now I have 2 logs, but they're on each side, left and right. When you have something like this, and you have the same natural log on both sides, or you have a common log on both sides, or even if you have log base 7 on both sides, if you have the same exact log, this is a 1-to-1 property, you just set 7x minus 4 equal to 2x plus 11. And then you solve. Okay, subtract your 2x, that gives me 5x. Add your 4, that gives me 15. X is equal to 3. you would plug it back in and check. Right now, I'm not going to do it in the calculator. I'm just going to walk through it. If you plug a 3 back in here, do I take the log of 0 or negative? No. If I plug a 3 in here, do I take the log of 0 or negative? No. So I'm okay. All right. So my next one, I have 2 log base 3 of 6 minus 1/4 log base 3 of 16 equals log base 3 of x. Notice that I have multiple logs on the left. The one on the right is by itself, so that's okay. The 2 on the left, I'm going to have to condense. Okay, so these are when I use my condensing properties. Now those coefficients are going to become the exponents, and I'm also going to divide those 2 terms. Okay, so I have log base 3. I'm going to take 6 squared and divide that by, if I'm doing 16 to the 1/4 power, that's the same as the 4th root of 16. All I did was rewrite it in radical form. You should be able to go from one form to the other. And that's equal to log base 3 of x. So 6 squared is 36. What's the 4th root of 16? Should be 2. And that is equal to log base 3 of x. Now what's 36 divided by 2? 18. So I have log base 3 of 18 equals log base 3 of x. So what does that tell me? X equals 18. I do not divide by log base 3. Never divide by just logging your base. That's going to be wrong. Okay, this is your one-to-one property, x equals 18. Okay, the next one, I have log of z plus log of z plus 3, and that is equal to 1. I need to do what? I need to condense it, right? I have 2 logs separated with a plus. What does that tell me? I'm multiplying. What am I multiplying? 7 and the, not the 7, the z and the z plus 3. I'm sorry. So when I multiply that, you can go straight to the multiplied form of z squared plus 3z, and that is equal to 1. Now I've condensed it to 1 log. What's the inverse of log? Exponential. I don't have a one-to-one property here because I only have 1 log. Okay, so when that's the case, you rewrite it to exponential. So I need a base. What's my base? It's not written, so it's understood to be 10. So whenever I rewrite it in exponential, I have log base solution equals exponent. So I'm going to go in that counterclockwise direction, and I'm going to take 10 to that first power equals z squared plus 3z. Okay, anytime you have a squared term with its variable, this is when you want to factor. This is a quadratic. So you're going to get it equal to 0 and factor. So I'm going to subtract that 10 and move it to the right. So I've got z squared plus 3z minus 10 equals 0. Now I'm going to have to factor that. What is that going to factor to? Z plus 5 and z minus 2. Good. So what does that tell me my z values are? -5 and +2. Now, if you're not checking, you're going to box both of those and move on. But if I take this -5 and plug it in for z, what happens? You're taking the log of a negative. which I cannot do, so that's extraneous, the 2 will work when you check it. Okay. I know I'm going fast, but you're not following me. All right, this next one, I have natural log of x equals 6. This is a super basic one that we can do very quickly. I was going to skip it, but we can do it. Okay, I have no isolating to do. If I'm looking at natural log of x equals 6, I automatically put it in exponential form. I'm starting with log, it's isolated, my only inverse is to do exponential. So how would I write that in exponential form? E to the 6 equals x. And then I just type e to the 6 in my calculator. So you press your E button, put your 6, x is equal to 403.429. Okay, so not every problem is super extravagant with the work. Okay, but I think I more than likely took those off. Like I omit those on this worksheet since y'all have 2 worksheets this time. So my next one I have log base 3 of y equals 1/4 log base 3 of 16 plus 1/3 log base 3 of 64. Okay. What do I need to do? I need to condense. Okay. So I have coefficients that become the exponents. And I have a plus. What does that plus tell me? I'm going to multiply. So I've got log base 3 of y equals log base 3. I am multiplying the 4th root of 16. How do I know it's the 4th root of 16? Because this is 16 to the 1/4 power. And I'm multiplying that by what? The cube root of 64. And again, I know that because this is 64 to the 1/3 power. Okay, so I have log base 3 of y equals log base 3. The 4th root of 16 is 2, and the cube root of 64 is 4. So log base 3 of y equals log base 3 of 8. What do I know about that? Y equals 8, my 1-to-1 property. Okay. So my next one, I have natural log in parentheses 2 minus 3x plus 4 equals 7. What do I do? Subtract the 4. So natural log of 2 minus 3x equals 3. And then what do I do? Exponential form. I have my natural log isolated, so the inverse of natural log is e raised to a power. So I've got log base solution equals exponent, right? So if I read that to myself every time, then I should know to put in exponential form, I have e to the 3rd power equals 2 minus 3x. So then I have e to the 3rd power, which is 20.0855 equal to 2 minus 3x. And then if I just have a decimal there, what do? I solve for x like I would as if that were a whole number. What do I want to get rid of? The 2, so I subtract 2, that gives me 18.0855 equal to negative 3x. Then divide by negative 3, so 18.0855 divided by negative 3 gives me x equals negative 6.0285. Again, you might have a little decimal that's off if you're not rounding. So if I just took this and subtracted 2, then divided by negative 3, it's going to give me, this one rounds to the same thing, but some of them might round a little differently. Okay, so just be careful with that. Okay, we good? We've made it to our last one. Okay, so we have natural log of negative 3x plus 1 in parentheses equals natural log of 4x plus 4. I want you to very briefly, well, I say briefly, quickly, talk with the person next to you or near you if you're by yourself. What would you do with this problem? I'm going to give y'all like 2 minutes to talk about what you would do. Yeah. Okay, what do you think you do? How? So the one-to-one property? Yeah. Okay, how many of y'all would do the one-to-one property here? Okay, that's everyone's instinct. So I have less people in here than yesterday. Everyone's instinct is to do that because you see a natural log on the left and a natural log on the right, and it looks the same, right? But I can't do that because that plus 4 is not part of that natural log. What's the difference between the left and the right? Parentheses. I have parentheses on the left, which makes that negative 3x plus 1 part of that natural log. But see how I'm lacking those parentheses on the right. So that means you cannot assume that the plus 4 is part of that natural log. That 4x is the only part of that natural log. That's why every year I ask y'all to think about it. Because you have to notice those small details. Parentheses are very minor in, but that's like missing a comma in a sentence. Okay, that makes a big difference in the meaning of it sometimes. And so the parentheses here would change this completely. Knowing now that these are two separate terms, what should I do? Move it over so that I can condense. Okay, so I'm going to have natural log of negative 3x plus 1 minus natural log of 4x, and that is equal to my 4. Now I have a minus. What does that tell me? I'm dividing negative 3x plus 1 by 4x, and that is equal to 4. Okay, I've got my natural log isolated. It might look different than what all the other problems look like, but it's isolated. So then the inverse of natural log is exponential with a base of e. So I have e to the fourth power equals that negative 3x plus 1 divided by 4x. Okay? So e to the fourth power in my calculator is going to give me 54.5982. That is equal to negative 3x plus 1 divided by 4x. And then I'm going to do what? If I have a fraction, I need to get rid of that fraction by multiplying by the denominator. And it's okay that it has an x with it as long as you carry the x as you do your work. Okay, so that gets rid of my denominator. I take 54.5982 and multiply it by 4. And that gives me 218.393. Make sure you do not drop that x. You still have an x on it. And that is equal to negative 3x plus 1. So even though it looks weird, I have an x on the left and an x on the right, I need to add that 3. So I have 221.393x equals 1. And then how do I solve for x? Divide everything by 221.393. So in your calculator, you are dividing 1 by 221.393. So x is equal to 0.0045. Okay. Now remember, you need to be plugging those in. So even on the example we just did, just because it was negative did not make it extraneous, because when I plug that back in, I have a negative 3 times that negative. So that would be a positive. It does not make it extraneous just because it's negative. Okay, so that's the end of 7.5. Before